I want to take just a brief moment to talk about first order linear differential equations. We've talked about second order a lot. You might think, okay, that's a bit out of order, right? Why did we talk about 2 before we talked about 1? A theme in solving differential equations is that you can sometimes reduce the order of the equation. So if you're presented with an order 3 equation, you can somehow formulate a related order 2 equation, solve that, and then use the solution of the order 2 equation to get the solution of the order 3 equation. We've seen this already in the variation of parameters approach, where we had an order 2 equation, and what we needed to do was set up an order 1 equation, that is an equation involving u1 prime and u2 prime, and then we had to integrate u1 prime and u2 prime to get u1 and u2. You can think of this as a first order equation. It just happens to be pretty simple to solve, right? Once you know u1 prime, you have to integrate to get u1, no sweat. So if we start from an equation of any order, say order n, you can sort of successively go through and decrease until you get to first order. If you remember, in the variation of parameters approach, actually you get to first order right away. But at the end of the day, you have to understand how to solve first order equations. So I just want to briefly go over this. This may be review for you from a high school calculus course. If you took Math 104 at Penn, it's covered there. But let's go ahead and go over it, because it's probably been a while. So the general form of a first order linear differential equation, or a FOLDY, is something times y prime plus something times y equals something. Everything in sight's allowed to be a function of x, just not a function of y. As is our custom, we want to make sure that first coefficient is 1. So if we divide through by a, that gets us to what's called standard form, where you've got a 1 in front of y prime, and then I guess p better be b over a, and q better be r over a. Okay, that's the standard form of a FOLDY, and the trick here is to use the product rule. The way we do that is we multiply both sides by e to the integral of p. This thing that we multiply both sides by is called the integrating factor. And the only thing you have to notice about the integrating factor is that when you take its derivative, you get a copy of it times p, and that's just the chain rule and the fundamental theorem of calculus. So let's put that together, and now we're going to apply the product rule. We've got the integrating factor times y prime plus the derivative of the integrating factor times y. And so the left-hand side is somebody's derivative. Well, we know how to solve the differential equation where one side is somebody's derivative. You just integrate. And then we can solve y by dividing by the integrating factor. As a formula, that's sort of obnoxious to remember, but the trick is, if you do it in practice, you sort of get the hang of it. Let's do an example. So let's take a look at this equation. It's t squared dx dt plus 2t squared over 4 minus tx equals 5t squared. Notice that's linear, but this is in the general form. It's not in the standard form. So the first trick is to put it in standard form, which we do just by dividing by whatever's in front of dx dt. That lets us identify our p and our q, and now we can compute the integrating factor. So that's the integral of p, and then the integrating factor is e to whatever that is. It's probably a good idea at this point to simplify that log, since I've got an e to the something. Okay, and now we're ready to multiply both sides by that integrating factor and integrate. So we'll end up with on the left and on the right. Okay, so that means that 4 minus t to the minus 2 times x is whatever the integral of 5 times 4 minus t to the minus 2 dt is. Working that integral out, you get 5 over 4 minus t plus c. And now that plus c is important, right? When you compute the integrating factor, you don't need a constant of integration. That's because the integrating factor, any old function will work, right? It doesn't actually really matter which integrating factor you pick. You just need some function that lets you use the product rule. On the other hand, when we're doing this integral on the right-hand side, we definitely need this. That makes sense. This is a first order equation, so there should be one parameter, right? One coefficient we have to determine because the solution set is one-dimensional. Let's go ahead and finish the problem. And to finish the problem, we just multiply through by 4 minus t squared. And that's our solution. Notice we still have that one parameter.